starting the recording of today's lecture. Very well. So we are on chapter 4. We're going to continue 4.2. So what are the objectives? So objectives for today's lecture is we're going to talk about binomial CDF. Binomial CDF, cumulative density function. Okay, very well. So let us finish the lecture today. Then we're going to have our quiz. Very well. So first of all, we are on page, let's take a look at our page. We are on page 3. Page 3. And I'm going to review what we learned so far. We learned about a binomial experiment. Binomial experiment. A binomial experiment must follow some conditions. The first condition is you have fixed numbers of trials. Fixed numbers of trials. This is fixed, definitely. Trials are independent from each other. Trials are independent from each other. What's the meaning of that? It means that whatever you do, whatever you take, you have to replace it back. Well, you only have 2 outcomes, 2 possible outcomes. It's either a failure outcome or it's a successful outcome. So successful outcome or a failure outcome. So for success, we have probability P. For failure, we have probability 1 minus T. And finally, variable X, random variable X, actually counts the number of successful tries, counts the number of, not the probability, the number of successful tries. Now, we had an example on page 3. This example said, suppose you're a surgeon and you're performing surgery on 3 patients. N is 3. And based on previous experiments, they know that P, or the probability of success, is equal to 90%. So 0.9 or 90%. So the question asks, what is the probability that you have exactly 2 successful surgeries? The probability of having exactly 2 successful surgeries. Remember that X counts the number of successful tries. X is 2 successful surgeries. To find this probability, remember that we use our calculator. We turn on the calculator, second, bars. And after that, based on TI-83, TI-84, or your online emulator, you have to find binomial PDF. Then you enter the information that you have. If you are using TI-83, you have to write N, comma, P, the probability, comma, X. And if you are using TI-84, it actually gives you N, number of tries, then P, then X. Then you get your information, you get the probability, which in this case was 24.3%. So P of X equals to 0.240 or 24.3%. Very well. So today we're going to talk about binomial CDF, cumulative density function.
And n is 2, not 3.
Okay, let us get back to some algebraic concepts and how to translate those into mathematical symbols. So what's the meaning of less than? Less than. What is the symbol that you're using for less than? What if you have less than or equal to? What symbol you're using for this? What is greater than? How do you translate greater than into English? Math symbol. What about greater than or equal to? What are the symbols in math that you're using? Less than, the symbol that you're using is inequality, less than. Less than or equal to, less than or equal to. Greater than, the symbol that you're using, inequality, greater than or equal to has equality next to it. So what if you have the word at least? What about at most? So at least, it means that you start from a value, you include that, and you go up. So when you see at least in a question, the meaning of that is greater than or equal to. So these two have the same meaning. At most means that less than or equal to. At most.
And is it a keyword?
Let us take a look at one example and try to translate that example using the symbols that we just learned. Very well. So in example on page 4, you have a survey of US adults found out 62% of women believe that there is a link between playing violent video games and teens exhibiting violent behavior. What is this 62%? What do you think? Is it N? Is it X? Is it P? Is it Q? What is that?
P.
Very, very well. Excellent. Very well. What is P? P is, very good, the probability of success in one try. Excellent. You randomly select four US women. So what is this for?
X.
What is this for?
N.
This is number 4, N. Excellent. Yes, perfect. Thank you, everyone. This is N. N is 4. The number of fixed trials, or N, is equal to 4. And ask them whether they believe that there is a link between playing violent video games and teens exhibiting violent behavior. Find the following. Find the probability that, 1, exactly 2 of them respond yes. 2, at least 2 of them respond yes. 3, fewer than 2 of them respond yes.
So let us specify these, write them down on the board, the information that we gathered here. We are on page 4 and our example. Page 4. Well, as we identified, P, or the probability of success in one trial, is 62%. 62%. What is N? We ask exactly for USD. So, question 1 asks, what's the probability that X is exactly 2? 2, what is the probability that at least X is 2? And 3, what is the probability that fewer than 2 of them responded yes? X is fewer than 2. Perfect. So for the first one, X is exactly 2. Since X is exactly 2, X is exactly 2, it means that you're finding the probability that X is equal to 2. You're going to use your calculator. Go to second, vars. Go to second vars, binomial PDF. Binomial PDF. And find the probability here. Okay, take your time. Very well. So what do we have here? We have second vars. Then we're going to find binomial PDF, enter. How many trials? We ask for women. The probability is 62%, so 0.62, and exactly 2 of them responds yes. So the probability is 0.3330. It's going to be like 33.3%. So the first probability that we calculated is 0.333 or 33.3%. Exactly 2. Now, at least 2 of them. What's the meaning of at least? Greater than or equal to. So it means that we're finding the probability of 2 or 3 or 4. The probability of 2 plus probability of 3 plus probability of 4. Okay. Take your time, find the probability. Very well. Here we have our calculator. So let us calculate P of 1 first. Binomial PDF 4 and X is 1. So this probability is 13.6. We can write the rest of it to have a precise value. So 0. We don't need 1, we need 2. 0. This is 0.333 0, 4, 4, 16. So now let us find the probability of having exactly 3. 3, so let us find our binomial PDF. And here you have now 3, exactly 3, which is equal to 0.3622 plus 0.3622, 58. Continue that. Now get a precise value. And finally, the probability that it is exactly 4. So P of vars, let us find binomial PDF, exactly 4. So X is 4. Here we go, 0.1477. And 77, 63, 36. And if you add all of these together, by adding all of them together, you get, what do you get? What would be the sum? If you add them all together, Q of 2, Q of 3, Q of 4, because it says at least 2. So 2 probability of X equals to 2, probability X equals to 3, and probability X equals to 4. What would be your answer? What would be the sum?
84.3%.
84.3%. Very good. How about part 3, question 3? It says X is fewer than 2, less than 2, fewer than 2. So less than 2, what are the numbers less than 2?
0 and 1.
0, 1. So probability that X equals to 0 plus the probability X equals to 1. You need to find these two probabilities, add them together, do that, then I'm going to show you how to use binomial CDF to actually calculate these.
So no 2?
Okay, so now we're going to use a new function, binomial CDF. How do we use that? Your calculator actually has that function and you can use it. It actually counts the probability less than or equal to a value. So if the question says find the probability of values less than or equal to A, you go to your calculator, second, vars, binomial CDF, and you punch those values in. A, for example, if A is equal to 2, you just punch 2 for A. So this is the case that you have less than or equal to. You just go to your calculator, second, vars, binomial CDF, and P, comma, A. I expect you to ask, what if equality is not included? How can I use my calculator? In that case, you go to second, vars, binomial CDF, and P. You have to subtract 1 from the value that you have. For example, if the question says find the probability of all values less than 2, you're going to go to second, vars, binomial CDF, and P. Instead of writing 2, you have to subtract 1 from 2, which gives you 1. Okay, 2 more cases.
If your question says, find the probability that x is greater than a, more than a, this is equivalent saying that you have 100%, which is 1, minus the probability of the values that are less than or equal to a. We know that our calculator has less than or equal to a. The only thing you have to do, you have to find that probability, subtract it from 100% or 1. And finally, if the question says, find the probability that x is greater than or equal to, if you have equality, greater than or equal to a number, it is equivalent saying that you are subtracting the probability of values less than a from 100%. So to find this value, p of x less than a, you have to go to second vars binomial CDF, punch in p and a minus 1. Then subtract it from 100%. So let me erase this one. And we're going to get back to previous example. So in previous example, what we had? In previous example, we had the following. N was 4, P was 62%, and we wanted to find the probability that x is exactly 2. B, find the probability that x, okay, let's see, x is at least 2. At least 2. C, you wanted to find the probability that x is fewer than 2. X is fewer than 2. Very good. For the first one, since you have exactly equal to, there is no option. You have to use binomial PDF. So second vars binomial PDF, and you punch the numbers. 4, comma, 0.62, comma, here you have 2. We don't have any other options. X is at least 2. What's the meaning of at least? This is P. X is greater than or equal to 2. X is greater than or equal to 2. At least. So this is equivalent saying that you have 1 minus P of x less than 2, or 1 minus binomial CDF, for 62%, 0.62, and since it is less than, we have to subtract 1 from 2 as well, 1. Finally, the last one, x is fewer than 2. This one says P of x less than 2. Since it's less than, you have binomial CDF, for 62%, and 2 minus 1, which is 1. So let us use our calculator. We already know the results. We already did our calculation. Let us take a look at our calculator using binomial CDF.
I have question and x.
Okay, guys. So we want to find the probability that x is at least 2. So it is 1 minus, we have to find subtraction, 1 minus binomial CDF. So second
vars. You have to find binomial CDF, enter. The number of trials is 4, probability is 62%. And remember that since it's less than, you have to write 1. Enter, enter, enter. And as before, we got 84.3%. So when you're using binomial CDF in this example on TI-84 or TI-83, first of all, you need to do the subtraction. So it is 1 minus 1 minus. Now move on to second vars. Find your binomial CDF. Enter. Number of tries is 4. Probability is 62. And your X value must be 1. Enter, enter, enter. You get 84.3%. Well, for part C, let's take a look at our emulator. What do we have? We have P of X less than 2. So it is actually second vars. We have to find binomial CDF. Enter for 62% and X is equal to 1. So enter, enter. As you can see, we get 15.6%. Let us use our TI-84. So here you go to second vars, binomial CDF. The number of tries is 4. Probability of the success is 62%. And X value is 1. X value is 1. We have to subtract 1 from 2 because it's less than. Now enter, enter. You get the exact same probability, 15.69%. As before.